Welcome to another exciting math lesson. Today, we're diving deep into the fascinating world of quadratic functions. By the end of this video, you'll master how to analyze these functions, understand their graphs, and identify their key features with confidence. So what exactly is a quadratic function? A quadratic function is any function that can be written in the form f of x equals a times x squared plus b times x plus c, where b and c are constants and a is not equal to 0. The graph of a quadratic function is called a parabola, and it has a beautiful U shape that can open upward or downward. Let's start with a specific example. Consider the quadratic function f of x equals x squared minus 4x plus 3. Our goal is to analyze this function completely, finding its vertex axis of symmetry, X-intercepts, a Y-intercept, and understanding its behavior. First, let's find the vertex. The vertex is the turning point of the parabola, either the minimum or maximum point. We can find the x-coordinate of the vertex using the formula x equals negative b divided by 2a in our function. A equals 1 and b equals negative 4. Let's substitute these values. We get x equals negative times negative 4 divided by 2 times 1. This simplifies 2x equals 4 divided by 2, which equals 2. Now that we have the x-coordinate, let's find the y-coordinate by substituting x equals 2 back into our original function. We calculate f of 2 equals 2 squared minus 4 times 2 plus 3. This becomes 4 minus 8 plus 3, which equals negative 1. Therefore, our vertex is at the point 2, negative 1. This is the minimum point of our parabola since a is positive. Next, let's identify the axis of symmetry. The axis of symmetry is a vertical line that passes through the vertex and divides the parabola into two mirror images. Since our vertex is at x equals 2, the axis of symmetry is the line x equals 2. Now, let's find the y-intercept. The y-intercept is where the graph crosses the y-axis, which occurs when x equals 0. Substituting x equals 0 into our function, we get f of 0 equals 0 squared minus 4 times 0 plus 3, which equals 3. So our y-intercept is at the point 0, 3. Moving on to the x-intercepts, also called roots or zeros. These are the points where the graph crosses the x-axis, which happens when f of x equals 0. We need to solve the equation x squared minus 4x plus 3 equals 0. We can factor this quadratic expression. Looking for two numbers that multiply to 3 and add to negative 4, we find negative 3 and negative 1. So we can write this as x minus 3 times x minus 1 equals 0, using the zero product property. If the product of two factors equals 0, then at least one factor must equal 0. This gives us x minus 3 equals 0, or x minus 1 equals 0. Solving these, we get x equals 3 and x equals 1. Therefore, our x-intercepts are at the points 1, 0, and 3, 0. Let's also determine the direction of opening. Since the coefficient a equals 1 is positive, our parabola opens upward. If it were negative, it would open downward. Finally, let's talk about the domain and range. The domain of any quadratic function is all real numbers, since we can substitute any x value. For the range, since our parabola opens upward and has a minimum value of negative 1 at the vertex, the range is all y values greater than or equal to negative 1. Let me summarize what we've learned. To analyze a quadratic function, we identify the vertex using x equals negative b over 2a. Find the axis of symmetry. Determine the y-intercept by setting x equals 0. Find the x-intercepts by solving the equation f of x equals 0. Check the direction of opening based on the sign of a, and establish the domain and range. These key features give us a complete picture of the quadratic function's behavior. If you found this video helpful, don't forget to subscribe to MathVer for more amazing math content. Hit that notification bell so you never miss a lesson. Now, here's a challenge for you. Try analyzing this quadratic function on your own. f of x equals negative to x squared plus 8x minus 6. Find the vertex, axis of symmetry, intercepts, direction of opening, and range. Write your answers in the comments below. I'd love to see your solutions. Good luck, and keep practicing.